Hi, everyone. Welcome back. We're in sixth grade. This is Unit 7, and we're on Lesson 5 today. Today's lesson, we're going to learn about part to part ratios, which we've been talking about a lot, and their relationship to part to whole ratios, which we really haven't talked about much, but is a really important way to talk about ratios because sometimes we want to know one part compared to another part of something, but sometimes we want to know how much of the whole thing, one part compared to the whole thing. So, to do that, we're going to look at some fruit snacks today because I know that my family have some favorites out of the choices, and you maybe have certain ones that you like better, or other things. Starburst, for instance, cherry, all the way. The whole pack could be cherry for me. What about you? What are your favorite Starbursts? So, be thinking about what that could mean with part to part and part to whole. All right, so you can see I opened up a few pack of fruit snacks, and this is what we've got. So these are what we've got. So in order to be able to compare them, first of all, we have to what? Sort them. Remember in our last unit, we talked about that algebra is a lot of sort of sorting and matching things that go together. Well, ratios are too. In order to talk about ratios, we've got to put what goes together together. So if you're doing this along with me, which I really hope you do, you hear me say it all the time, don't just sit and watch me play with math. Please, you too, play with math. So if you happen to have some fruit snacks lying around and you're in the mood for a breakfast of fruit snacks. Maybe you can share some with your family, not just eat all of these yourself. But grab some fruit snacks and sort them out with me. Or if you don't have fruit snacks, that's fine. Grab a handful of Legos or grab some rocks or whatever it may be. Grab some kind of cereal that has different things that, like Lucky Charms, where it has different kind of marshmallows or whatever. So grab something to sort it out so we can talk about ratios part to part and part to whole. So pause the video, go do that. When you come back, I'll have sorted these as well. Okay, so now, whoops, I'm sliding a little bit. Now that I've got them sorted, it's easy to tell at a glance which ones have more and which ones have less. So we can easily see that the ones that are shaped like cherries, the cherry ones, there's only two of them in all those packs that I opened up, and I think I opened 3 or 4 packs, I can't remember. There's 4 strawberries, there's 4 apples, 3 grapes, 5 raspberries, and how much is this? 5, 10, 10 oranges. So there's kind of a big difference. Okay, so what's your favorite? Well, on stuff like this, I usually like grape and I usually like cherry. Those are my usually two favorites. So I'm going to compare the grape to the cherry because those are my two favorites usually. So I'm going to compare grape to cherry. So the grape has 3, the cherry has 2. Which number do I have to put first? Well, I hope you said if you're comparing grape to cherry, the grape number has to come first. So I could write 3 TO2, 3 to 2. Or I could write 3 colon 2, 3. We still read that 3 to 2. Or I could write 3 with a fraction bar 2, 3 to 2. All of those ways are ways to talk about the grape compared to the cherry. But even though I like those two grapes and cherries best, if I had a whole choice like this, I probably wouldn't compare the grape to the cherry, would I? If those are the ones I liked best, what would I really want to know? How much of either of those, or maybe both of those, compared to all of the other choices? Because that's what gets me in Starburst, and I wish I had some Starburst here. But I really like the cherry ones. I wish they made a whole pack of cherry. So I want to know how many cherries are there going to be compared to all of the Starbursts? Because I'm going to just give away all the lemons. I don't like the lemons at all. The orange ones they're okay. So maybe I would eat them, maybe I'll give them away. The strawberry ones are okay. I would eat those, but I really like the cherry. You might be the same with something like this. So normally, if you are, you probably would not want to compare just the color to the color that you liked. You'd want to compare the color that you liked compared to how many there were. So let's instead compare the number of grape to all of the fruit snacks. That's what I want to know. What's the ratio of grape ones that I really like to however many there are altogether? So we know it's still 3 to something. because it's grape to all. But to get the all, we have to know how many are on the plate. Well, I don't actually know that, so I'm going to pause for a second and count. All right, so there's 28. So only 3 out of 28. 3 to 28, or 3 to 28, or 3 to 28. And oftentimes we would use the words out of there too. 28. Only 3 out of all those are the ones that I really like best. But there's 2 different ways to talk about them. Part to part, where I'm talking about 2 of the parts, or part to the whole thing, where I'm talking about 1 part compared to the whole thing. But occasionally, and this really tricks kids, so stay with me for one more time of part to whole. This part to whole is especially tricky. Remember I said that grape and cherry are my 2 favorites? Oftentimes we want to know what the 2 favorites are compared to the whole. So let's see what that could look like. All right, now this is a tricky one, and this kind of question shows up on those hard tests we have to take on the computer from time to time. The standardized ones that we take, or the ones like our iReady and whatnot. These are the kinds of questions that really trick kids because it asks what's the ratio of either grape or cherry to the whole? What they're trying to get at, and they don't give us all that background about what we like. So we have to fill that background in, and that's especially tricky for a lot of math. You might just see numbers, and remember, you hear me say, numbers aren't just numbers; they always mean something. And if it doesn't tell you what they mean, you have to figure out something about what they mean to understand them better. So if they say grape or cherry, we want the ratio of grape or cherry to the whole thing. What they're really saying is somebody wants to know, I like the grape and the cherry best. And I want to know of all of these fruit snacks that I open up, how many are going to be my 1 or 2 favorites? And my 1 or 2 favorites are grape or cherry. So I really, really like grape, but I really like cherry too. So either one is good. I want to know the ratio of either of those to the whole. So I have to look and say, well, I'm going to put those kind of together in a group because it says it could be either grape or cherry right there. So that's a group compared to the whole thing. So either grape or cherry together is 5. There's 5 of them that are either one or the other. Then we know the whole is 28. So these kinds of questions where they ask us, is it one thing or the other compared to the whole? They really need a context around them. You really have to think, why would they be asking that, or what are they trying to get at? And they want to know in this case, I want to know which ones are my favorite and out of the total. So 5 to 28, or 5 to 28, or 5 to 28. I hope that context helps you because you will definitely run into these kinds of questions, both in this unit as we're learning, and then also on all of those tests. And they're hard. So you got to put a context around it, and then you'll be just fine. Okay, let's get into our day's lesson today in the book. So they're mixing kiwi fruit juice and strawberry juice to make a really yummy blend of kiwi strawberry. Now, I went to the grocery store last week with a list all through the unit of things I wanted to buy so that I could have these here to show you. And it is almost impossible to buy some of these juices independently. So I don't know why I did it. So look at this. So you go and they have like apple, peach, mango, which, okay, it has apple and it has peach and it has mango and it sounds super yummy. But for me to buy only apple juice, pretty easy. Peach juice, hard. Mango, hard. So instead of being able to buy all these 3, the only thing I could find was where they already mixed it, apple, peach, mango. So that happened to me with kiwi strawberry too. I couldn't find the kiwi juice and the strawberry juice like they're telling us to mix today in today's lesson. I could only find already mixed kiwi strawberry. So So instead, I've decided to show you the tape diagram. And they're talking about tape diagrams, and really all it is using a chunk of something to show as if you had a long, giant piece of duct tape, and part of it you chopped off along the way. So instead of taking duct tape and putting duct tape all over my dining room table, maybe that wouldn't be such a great idea. Instead, I got a whole bunch of different color sticky notes and thought that could really help us. So we're going to use sticky notes to show the tape diagram. And I can't actually show you the juice as it actually is because it's already mixed. That's how they sell it. So here we go. Let's dig into the unit. Okay, so here's their recipe for kiwi berry juice. It has 2 parts of kiwi, and it has 3, oops, that's really hard to read there. There we go. And it has 3 parts of strawberry juice. So 2 parts to 3 parts. Now, when it says parts, that's kind of like when we say units in math. We're talking about a length, a distance, but we're not saying it's meters or inches or yards or centimeters, whatever. It could be any of those. That's what parts mean in ratios. When we say 2 parts kiwi juice, it could be 2 cups to 3 cups strawberry. But it could be gallons. Maybe you're making it for a party. It could be 2 gallons of kiwi juice compared to 3 gallons of strawberry. It could be like you saw in one of my last videos where I was trying to make it, but I didn't want to make a ton because I didn't know if I was going to like it. Tablespoons. It could be 2 tablespoons of kiwi juice to 3 tablespoons of strawberry if you just want a little taste. So parts just mean the same measurement unit, but it doesn't matter what it is. So 2 parts kiwi to 3 parts strawberry. Let's measure that with a tape diagram. So you see, I have our sticky notes, and I chose pink for strawberry and green for kiwi. So it tells us that we need 1, 2 sticky notes in our tape diagram compared to 1, 2, 3. Now that matches up really, really well with what we have right there, doesn't it? It's easy to see how that makes sense. We had 2 parts of kiwi juice, so we have 2 parts of our tape diagram that's kiwi. We had 3 parts of strawberry juice, so we have 3 parts of our tape diagram that's strawberry. So that's easy to see and understand. I'm going to put a K on there because that's kiwi and strawberry and strawberry. So to start out modeling our tape diagram just according to what it says, that feels easy. However, sometimes they'll change how much each of these is worth. When it's just 1 to 1, this is 2, so there's 2. There's 3, that's 3. Easy. Hold on though, let's see what they do for us. That makes it a little tricky. All right, let's look at the example I'm on page 351, and this is number 7. Actually, sorry, I got ahead of myself there. My book was on the wrong page. I'm going to start earlier on in the unit, and then we'll get to that in just a second. So I'm actually on page 349, and this is number 1. So you'll see we originally put down, this is 2 parts to 3 parts. So we put 1, 2, 1, 2, 3. But number 1 now tells us that this part with 3 on the tape diagram of strawberry actually is equal to 15 liters. Now, this is what I was talking about where they change what it's worth. So this is 15 liters. So we need to figure out how much that is. This is 3 parts, but the 3 parts, when we put them together, makes 15. So you're going to say to yourself, when we put 3 of the same thing together, it has to be worth the same. When we put the same thing together 3 times, what makes 15? Well, hopefully you're saying, hey, I know a fact that's going to solve that problem. I know what that is. It's going to be 5. So this is going to be 5 liters, 5 liters, 5 liters. Sorry about those 5s. It's going to look like S's and vice versa. It's kind of confusing. So those are going to be fives, 5, 10, 15. Well, so each of these are fives. So then we've got to figure out, this is 15 liters. How much is this going to be worth? This is 5. We figured out that 5 plus 5 plus 5 is 15. What's up here? Let's see how we can do that. The first way they want us to think about it is using this tape diagram. The thing that we didn't talk about when we say 2 parts compared to 3 parts is that those parts have to be equal. So it's 2 equal parts to 3 equal parts. So we have to have that word, oops, my Roomba's starting, hold on. We have to have that word equal in our mind. 2 equal parts to 3 equal parts. Doesn't say it in there, it's invisible, but we have to be thinking when we're talking about part to part that the parts are all equal. So if we look and know these parts are all equal, then if we have 3 equal parts of strawberry with 5 liters each, then we must also have 2 equal parts of kiwi, also with 5 liters each. So if the strawberry is 15 liters, the kiwi has to be 5, 10. The kiwi has to be 10 liters. And we can use this tape diagram to model it out and help us figure it out. So we already know the answer now, but the book wants us to be able to do it 3 ways. Using a tape diagram, modeling it out. They also want us to be able to do a factor puzzle. And they also want us to be able to use cross multiplication. So let's take this same problem through those 3 ways. So we've got the tape diagram. Let's draw out our factor puzzle. All right, so we got the start of our factor puzzle here, and we put the kiwi in the upper left, and then we chose the lower left to put the strawberry. Remember, when you're getting started, it doesn't matter where you put the numbers if you put them vertically or horizontally, and it doesn't even matter which one comes first. You just have to make sure that the rest of your numbers match up in the right spot. So they labeled this for us. This top row is kiwi. This bottom row is strawberry. So we know that anything that we put for strawberry has to be in that row. Anything we put for kiwi has to be in that row. So here's the 2 to 3. Now they also labeled us that this is one recipe, or the basic ratio. That's a recipe of 1. That's one recipe. But what they said is, what if we made a recipe that had 15 gallons of strawberry instead? So now we have to figure out, you can see where our factor puzzle develops. So we're going to start by saying, okay, 3 and 15 have some common factor. What is it? Well, it's 3. So we're going to put a 3 out there, where it's going to be in the 3 row. That means there's a 1 here. If there's a 1 if it's in the ones column here, we know on the multiplication chart it's in the ones column up above. 1 times something gives us 2, which is 2. If it's in the 2 row, it's in the 2 row all the way across, so we've got to have 2 on the other side. Now, over here, we've got 3 times something gives us 15. We know a fact, 3 times 5 gives us 15. So if it's in the 5 row column, down here, it's in the 5 column up there too. And 5 times 2 is 10. Is that what we got before? It sure is. It matches up. We said if we have 2 parts kiwi, but if we call each of the parts 5 liters, then our recipe here has 10 liters of kiwi juice and 15 liters of strawberry. So that's how that matches up with our factor puzzle. It wants us to do one more way, and that's cross multiplication. And if you haven't watched my videos before, or you've forgotten, you're saying, wait a minute, I already know one way. You showed me one way. Stop the video so I can start. That's all I need. You need more than one play. When you're playing sports, you need more than one play. When you're in math, you need more than one play. Because this works for some things and works really well, Might not work every time really well. This works really well for some things, might not work really well for every application. So we want to find ways that we can solve it so we can either check ourselves or think about things differently, or just some don't work all the time and we need to have other strategies. So let's try the cross multiplication strategy. All right. Notice I set up our cross multiplication problem exactly the same as our factor puzzle. Factor puzzles are just proportions written differently. So this is a proportion. When you write one ratio is equal to another ratio, we call that a proportion. And factor puzzles are the same. They just have boxes around them, like windows around them, rather than being just set to each other with an equal sign. Now, remember the strategy of cross multiplication means we're going to multiply from the top left and the bottom right. We're going to multiply those two things together. And then we're going to multiply the bottom right and the top bottom left and the top right together and multiply those two together. So on one of these crosses, we have 2 times 15. There it is. On the other cross, we have 3 times x. Remember, you can put a little multiplication sign in there if you want, or you can leave it out. You could just write 3x. Now we have to use cross multiplication. We have to use to solve this, we need to use the inverse operation. We want to isolate the variable, means we want to have x be on one side all by itself. We want to have whatever the mystery group is all by itself. Right now we have 3 groups of a mystery amount. We don't want 3 groups of a mystery amount. We want 1 group of a mystery amount. So we're going to divide by 3. Remember, the fraction bar is a way to write division. We're going to divide by 3. I don't think you've seen me do that before, but that's what that means. So if we have 3 groups of a mystery amount and we divide it by 3, all that's left is the mystery amount. If we have 2 groups of 15 and then we divide that by 3, 2 groups of 15 is 30. 30 divided by 3 is 10. So x equals 10. Look how all these ways, tape diagram shows we have 10 liters of kiwi juice. Factor puzzle, 10 liters of kiwi juice. Cross multiplication, 10 liters of kiwi juice. It wants us to know how to do all 3 of those ways. All right, now we are on page 351 and we're on number 7, and it's asking us to talk about the parts compared to the whole amount of juice. So when they say just compared to juice in general, and they don't say part to part or like this chunk to that chunk, just to the juice, it means when we mix them together, the whole thing. That's a little tricky. Those words can be a little tricky. You really have to read carefully and think about, are they asking us about a part of the juice, or are they asking about us about the whole thing? Okay, so we have our 2 parts compared to our 3 parts, and they tell us now that this whole thing, the whole amount of juice that's in the container is 50 liters. And we have to figure out how much of each part it is, knowing that the whole thing is 50 liters. Well, this is an easy problem to start us, isn't it? Because we say, oh, 50, I know I've got 5 equal parts of 50. What are those 5 equal parts of 50? Well, hopefully you're saying, well, 10. That's easy. This is the easy one. It is. 10, 10, 10, 10, 10, 10, 20, 30, 40, 50. When I put in 10 liters of kiwi, 10 liters of kiwi, 10 of strawberry, 10 of strawberry, 10 of strawberry, I get 50 liters. Easy. So it wants us then to solve that using the ratio, using the tape diagram, which we did, but it also wants us to then set that up as a factor puzzle and solve it, and set it up as a proportion and solve that using cross multiplication. So that one's easy. I'm going to let you continue with that one. Let's look at one that's trickier. Okay, let's look at number 9. Number 9 says if we have 7 liters of kiwi juice, first of all, how much would we need of strawberry? And then how many liters of juice can be made? How many of kiwi berry juice? When they say kiwi berry, That's the whole thing combined together in the container. Just like, remember, apple, mango, peach all together, when they say the name all together, that means how much just juice is in the whole container. So when they say kiwi berry, it's part kiwi and part strawberry. So how much juice of kiwi berry? That's the whole thing. So this is 7 liters. How are you gonna figure that out? I have had sixth graders tell me can't be done. 7 is an odd number that you can't divide that in half. You can. It's just not a whole number, is it? You could divide $7 in half. I could share that with 2 friends. I just wouldn't give them all whole dollars. You can divide 7 liters in half. It just isn't a whole number. What is it? It's 3.5. So this is 3.5. You can write it as that, 3.5. Or you could write it as a fraction. I'm bringing that closer so you can see that. Either one is fine. Doesn't matter which way you write it. But it's okay. You can have fractions when you're doing ratios, or you could have decimals. That's okay too. So that if these are each 3.5, what does that mean those? Those are all 3.5 as well. All right. So there's those. They're all 3.5. Now it wants to know how much kiwi berry juice we could make. Well, if we want the whole juice, we need everything. 3.5 and 3.5 and 3.5 and 3.5 and 3.5. We need to put all that in. Okay, so the total juice, all of this together, the total juice is 3.5 plus 3.5 plus 3.5 plus 3.5 plus 3.5, or 3.5 groups, 5 groups of 3.5. How much is that? It's 17.5 liters. Now, we've got the answer here, 3.5, 3.5, 3.5, 3.5, 3.5. We've got these answers. We've got what the total juice is. Let's look at what that looks like in a factor puzzle. All right, I've set the factor puzzle up with some of the labels the same as what we've seen earlier. Again, this is not the only way to do it. Don't get confused with that. But in order to keep some continuity to help us place things, I've set that up that way. So now we need to know one recipe, and we're putting all of the kiwi juice on this row and all of the strawberry juice on this row. So one recipe has how much kiwi and how much strawberry. Well, one recipe had 3.5 and 3.5. It had 7. Remember, one recipe of kiwi had 7 liters. How much did one recipe of strawberry have? Well, we haven't necessarily paused to figure that exact out. We wrote it out here, we figured it out, but how much is 3.5 and 3.5 and 3.5? Well, 3.5 and 3.5 is 7. So it's 10.5. So we have 10.5 there. Now, when we're figuring out the rest of the factor puzzle, we then want it compared to the total juice this time. So one recipe is 7 liters to 10.5 liters, but I'm going to put a T for total amount of juice. So this is 7 to 17.5. Isn't that what we decided? All right, pause. I told you wrong on that. Stop a second. As I was starting to write that down, I realized, wait a minute, I'm not showing you the right thing here. So sorry about that. Just rewind that. So instead of wanting to tell us kiwi to strawberry, because they're wanting us to find out the total amount of juice, it's actually kiwi to kiwi berry. So the 2 lines that we're going to use are kiwi, because that's what it tells us. We have 7 liters kiwi, and then the whole juice, which is kiwi berry. So our 2 labels are kiwi and kiwi berry. Now, I have a circle down in that part because when we look at the book, it tells us that's the space they want us to have, like the X, the mystery number. So we need to know in one recipe how much kiwi juice is there compared to how much kiwi berry. Well, to do that, we can just look at our tape diagram, and this is where it's talking about the parts. So what are the parts of kiwi compared to the parts of kiwi berry? Well, the parts of kiwi are two. There's two parts of kiwi compared to parts of the whole juice. There's five parts of the whole juice. So it's 2 to 5, 2 kiwis to the whole juice of 5 parts. Then we have to say, okay, well, what about the total? And in this case, they're telling us that it's 7 liters. We used a total of 7 liters of kiwi in our juice. So this is just the part to the part that's given. And this now is telling us the total amount of juice that we use is 7 liters. So what's the total amount of juice that we can make of kiwi berry? And then we know how to solve factor puzzles. So you can go ahead and solve that. And we find that the answer is just the same as what we found here. All right, we're going to do the factor puzzle together because this is a time where you might say, I don't think a factor puzzle is the best way to solve this. It might not be. This is a hard factor puzzle. You might get stuck here and you might say, awesome, factor puzzles are great for some things, not so great for others, or harder. So let's look at this factor puzzle together. So we're going to look at the top row, 2 and 7. What is a common factor that 2 and 7 have? It's only 1. The only number that you can multiply times whatever to get 2 or 7 is 1. So we know 2 and 7, those are in the ones row. So 1 times something gives us 2. That's an easy one. If it's in the 2 column, it's in the 2 column down there. Uh-oh, you might start seeing a problem. Wait a minute. 2 times what is 5? Starting to get tricky. Let's go over here. 1 times something is 7. Easy, 7. It's in the 7 row. There we go. They're in the 7 column. So we're good. We're good with this. That was easy. Down here is the hard part. So what times 2 gives you 5? Well, if you're not sure, you might have to do this as a strategy. Something times 2 is 5. Now, what that also means is something times 2 equals 5. Remember, if we want to find that mystery answer on just one side, we want to have the x, we want to isolate the variable, we're going to divide each side by 2 because some number times 2, we don't want it times 2, we want to divide it by 2 to get rid of that. So x equals 5 halves. So this is 5 halves. Remember, these two things multiplied by each other give us this answer. So if we multiply 5 halves times 2, the 2 really crosses itself out, and we just have the 5. Okay, so the answer over there is 5 halves. You can also call that 2.5. That'd be okay too. But so this answer over here is 5 halves. Then we have to do 7 times 5 halves, and we get 35 halves, which also equals 17.5. So that's how it shows the answer here. But that's a trickier way to do it. So you might say, not sure factor puzzle is the way I want to go. Modeling might be easier, and solving a proportion might be easier. 2 to 5 is equivalent to 7 to something. 7 times 5 is 35. 2 times a mystery amount is 2 groups of the mystery amount, so 2 times x is 2x. Then we're going to do divide by 2 on each side because we want to get rid of that too. X equals 17.5. Good luck. See you next time.